Hi, let's start with the next problem. The ask of the problem is to find how long does a car move uniformly. A good way to approach the problem is to use the velocity time graph. So let's draw it here for our convenience. Okay, and we say like the car has x. Let the time be on the x-axis and velocity on the y-axis. So they say the car has moved with acceleration first, and then from a initial velocity of 0, so the 0 is accelerated to some velocity which we are to find out, and has moved uniformly for some time, and then it has again decelerated at the same rate of. So are these two same slopes? Yeah, that looks at least apparently slope. So let's divide the total journey of the car into different phases. Oh, sorry, yeah, that looks a straight line, good enough. So starting a problem here. So as we said, it's the time graph t. This is a velocity graph. So let us call this particular value where the car reached a velocity as v, and let's divide the entire origin. Let's divide the entire motion into different phases. Let this be a, let this be b, let this be c, let this be d. So, for each of the phases between AB, BC and CD, the car has had some displacement, which is x1, let's call it x1, x2, x3, and it has some times t1, t2, t3. Fine. So, it has accelerated at a rate of omega or w in this case, which is equal to 5 meters per second square, and of course decelerated at the same rate. So, to find the velocity of the car at the point A, we use the formula from kinematics, which is V equal to U plus AT. So, since U is 0 and A is equal to W and time is T1, so we get the value V equal to omega T1 or WT1 in this case. We'll catch up with x2 again. Let's find the velocity. So this is V equal to omega T1. Sorry to that. Yeah, that looks good. So here it's same velocity stays. So this would be omega T1 2. So to find the relation between T3 and T1, so let's use the same formula here. So we know that using the same formula, V equal to U plus AT. So V, we know it has again come back to rest, which is 0 velocity in this case. 0. U is the initial velocity, which is omega T1 is equal to omega T1 plus acceleration in this case is deceleration, which is minus omega, and time, which is the time for this period, which is T3. So solving this equation, we get omega T1 minus omega T3 equal to 0, which is omega T1 equal to omega T3. So cancelling both, we get T1 equal to T3. For time being, let us call this is equal to T. So we have a velocity omega T1, so this would become omega T. Okay, so now let's approach the remainder part of the problem. Yeah, so we have been asked to find what is T2 in this particular problem. So how do we solve it? What have we been else given? We have been given that the velocity or uniform velocity would be equal to omega T, and the average velocity is equal to 72 kilometers per hour. If you observe the other units, which is the acceleration, and the total time is given in meters and seconds, or the acceleration is given in meters per second square and the time in seconds. So let's convert this into meters per second for ease of conversion. 72 into 5 by 18. So why this? We'll probably have to explore in other videos. Force, so this would be 20 meters per second is the average velocity. So the formula for the average velocity is equal to total distance traveled, or total displacement in this case, by total time taken to cover the distance, which is equal to x1 plus x2 plus x3 by t1 plus t2 plus t3. So since we found that t1 equal to t3 is equal to t, so let's replace this as x1 plus x2 plus x3 by 2t plus t2. So taking it forward and to compute x1, x2, x3, so in this particular case we have x1 is equal to, okay, the formula for displacement in case of a uniformly accelerated body is equal to ut plus half a t square. So this would be, since u is 0, the entire term would be 0 plus half into a would be 5 or w here in this case, and t square. That's equal to 5 by 2 t square. So in this case, x2 would be equal, since it's a uniformly traveling body, is equal to velocity into time. As you know, velocity is equal to displacement by time. So x2 is equal to velocity into time. Velocity in this case, which we have found out here, is equal to omega t, which would be nothing but 5 into t. So omega t is equal to 5t. This is the t from this particular case. So Vt was actually equal to V into T2. So we have omega t into T2. Sorry for that, missed that. Into T2. So that's equal to 5t T2. Similarly, x3 in this case, we see that it has got a uniform velocity at the start and ended up with a at rest. So we can use the formula v square minus u square by 2a. As you know, v square minus u square is equal to 2as. So the displacement is being calculated in this particular formula. Velocity is equal, final velocity is 0 minus u square. U is equal to velocity which we have found here is 5t. So that would be equal to 25t square by 2 into 5. A is equal to W is equal to 5 meters per second square. That's equal to, and since it's a negative direction, it will be retardation, minus 5. So minus 25t square by minus 10. So that would be equal to, so 5 goes 2 times, 5 goes 5 times. So we cancel the minus sign. So it's equal to 5t square by 2. So we need to clear up some space for this particular problem. So I'll erase the top half of it. Oops, sorry. Yeah, that's good. And yes, we have enough space now. So now let's getting back to our problem at hand. The total time traveled is t1 plus t2 plus t3, or as we found out in the earlier. Excuse me, just need to activate the stylus. So 2t plus t2 as per the problem is equal to 25 seconds. So the average velocity, which is total distance traveled, is equal to 5 by 2 t square for x1 plus let's get the value from the bottom. It's 5t into t2. Oops, sorry. So I'll have to strike this. It's not a power here, it's a t2. So plus 5t t2 plus 5 by 2 t square by 25. So we found out that the average velocity is 20 meters per second. So substituting the values and doing a cross multiplication in this case, we get 5t square. How do we get 5 by 2 plus 5 by 2 is 10 by 2, which is 5t square plus 5t t2 equal to 500. So we know that 2t plus t2 is equal to 25 seconds. So substituting this particular value here, substituting the value of t2, so this can be rewritten as t2 equal to 25 minus 2t. So this would, the equation would be 5t square plus 5t into 25 minus 2t equal to 500. So if I can cancel out the 5s, 5, 5, and this would be 100. So the equation that I would get with t square plus t into 25, 25t minus 2t square equal to 100. Okay, we need to get some more space, I guess, to solve that quadratic equation. So let me just remove this bottom part. One sec, please. Yeah, got it. So now that we have enough space to solve our quadratic, now let's get back to the problem at hand. So rearranging the terms and solving t square and minus 2t square, we get minus t square plus 25t equal to 100. So rearranging the terms, the equation would be t square minus 25t plus 100 equal to 0. So using the process of factorization, we see that 100 can be established the product of by the product of two numbers as 20 into 5. So in that case, since these both are negative and this is a positive, we can take it as minus 20 into minus 5. For this, you'll have to wait. If you people, those who do not understand, you have to wait to refer to how to solve these quadratic equations. Okay, so t square minus 5t minus 20t plus 100 is equal to 0. So we have t into t minus 5 minus 20 into t minus 5. So t minus 5 into t minus 20. If you actually solve this particular equation by multiplying both, you will get the same equation which we have here. So from this point of view, we know that t is equal to 5 or t equal to 20. But does this solve the problem? No, it doesn't. So we actually have to find t2, and here we have this equation that 2t plus t2 is equal to 25 seconds. So if I were to substitute t equal to 5, then 2 into 5 plus t2, substituting in this particular equation which we have here, is equal to 25 seconds. So solving this would give t2 equal to 15 seconds. But we cannot say that this is the right answer till we confirm the other value. So trying to put t equal to 20 and trying to solve it in the same method, 2 into 20 plus t2 equal to 25, we see that t2 equal to 25 minus 40, where we get minus 15 seconds, which is not a valid number because time cannot be negative. So in this case, t2 equal to 15 seconds is the valid answer for this particular problem.